Welcome to Gymkhana TV. Today we will start a topic, electrostatics. From the word statics, you can easily understand we will deal with something which is at rest. This electro will tell you that the quantity of the material that we will take at rest here in this case is electric charge. So we will discuss electric charge. So here in our course we will discuss on electric charge which is at rest. That consists of the subject electrostatics. Now in your childhood you may have seen that if you rub your hair, dry hair with a comb and then take the comb to a piece of paper, small pieces of paper, definitely you have seen that the comb will attract the papers. The reason is that when you will comb your dry hair, the electrons will be transferred from your dry hair to the comb, and then when you will take that comb to the piece of the paper, then it will polarize the bits of paper and it will attract it. Now the question is that with how much force two charges will attract each other? That is given by Coulomb's law. That is given by Coulomb's law. This Coulomb's law states that let you have two charges. Let you have two charges. One is Q1 whose position vector is R1. Another charge is Q2 whose position vector is R2. Now the question is how much the force will be experienced by Q1 when there is charge Q2 and how much force will be experienced by Q2 when the charge when there is charge Q1. So if we join them, this is the direction of R12 and when we join them this is the direction of R21. So the force experienced by Q1 on this experience by Q1 by Q2 will be F12, that is force on Q1 by Q2. That is directly proportional to the charge Q1 Q2 product of the charges, and that is inversely proportional to the square of their distances, that is R12. So there will be a proportionality constant F12 is equal to, let proportionality constant K, so Q1 Q2 by, sorry I forget to put here one square, by R12 square. Now see, force is a vector quantity, so that means it should have some direction, and the direction is that when we join Q1 and Q2, this is the direction of the force, that is the direction of force is along R12, that is R12 cap. This is the force on Q1 by this Q2. By the same process we can find what is the force on Q2 by this Q1. That we will get as, let we are denoting it by F21, that is equal to K Q1 Q2 by R21 square R21 unit vector. Now, so now this K is called proportionality constant. This K has value 1 in CGS unit, and this K is equal to 1 upon 4 pi epsilon naught in SI unit. This 4 pi and epsilon naught is the relative, the permittivity. This is the permittivity of free space. And we can easily find the unit of K in SI unit. See, the unit of force in SI is Newton, this is meter square, this is Coulomb square. So unit of K in SI will be Newton meter square by Coulomb square. This is the unit of K. Okay. So we get Coulomb's law as F is equal to 1 upon 4 pi epsilon naught. We are writing this in SI unit Q1 Q2 by R square along the direction of R cap. Now see, this Coulomb's law will satisfy Newton's third law, because see, the direction of R12 is in this direction, direction of R21 is this direction. So we can write R12 is equal to minus of R21 with a vector sign or with a unit cap. Their direction is opposite. So we can write F12 is equal to minus of F21, which also satisfies the Newton's third law. Okay. Now, we will now discuss what is the electric field. We have a charge, positive charge here. First thing, if we have two positive charge or two negative charge, there will be force of repulsion. That means they will repel each other. And we know if there is a positive charge and there is negative charge, they will attract each other. That is, it is attractive force. Now we have one positive charge at this point. So when there is a positive charge at this point, definitely there will be some field surrounding this charge. Now if we want to bring a charge at this point, we are bringing one unit positive charge at this point. We have to do some work. Okay. So electric, that is given by electric potential. That electric potential is defined as the amount of work done. In bringing a charge from infinity, here is something infinity this side, from infinity to this point. This point has position vector r. So potential is defined as the work done in bringing a unit charge from infinity to this point. Let that force at this point is E and dr. Now what is E? We call this E as electric field intensity. Now the question is, what is electric field intensity then? Electric field intensity is, we know from Coulomb's law, F is equal to 1 upon 4 pi epsilon naught, product of two charges and square of their distance into the direction of the line joining them. Now we have two charges. This is Q1, this is Q2. That means Q1 is equal to Q and Q2 is equal to a unit positive charge. So definitely the force experienced by this unit positive charge, we can write it as F is equal to 1 upon 4 pi epsilon naught Q into 1 by r square into r unit vector. This is called the electric field intensity. This force is called electric field intensity. That means it is defined as the force experienced by a unit positive charge placed at this point. That is the electric field intensity at that point. Now how potential is defined? It is the work done in bringing a particle from infinity to that point. That means from infinity to that point, that is the potential. So see, now it is a dot product of two quantity. One is E, another is dr. What is E? E is Q by 4 pi epsilon naught r square. Okay, we are writing that from infinity to that point, Q by 4 pi epsilon naught r square into r unit vector dot. Now see, what is the direction of dr? We are bringing the unit positive charge from the infinity to that point. So definitely this is the direction of dr and the direction of electric field is along this direction. So they are opposite in direction. So that means cos of 180. So that is dr cos 180. Why we are applying cos? Because we know A vector dot B vector is equal to mod of A mod of B into cos of theta, that is angle between A and B. So similar formula we have applied. E dot dr is mod of E mod of dr cos of angle between them. Here it is 180. So by cos 80 minus 1, so we are getting minus infinity to r Q by 4 pi epsilon naught r square into dr. Okay. Mod of this value is 1. By solving, we will get Q by 4 pi epsilon naught r. So that means we get here, this was the Coulomb's law. Now we get electric field intensity, which is 1 upon 4 pi epsilon naught Q by r square r unit vector. This is the electric field intensity. That means force experienced by a unit positive charge placed at that point Then we get potential, that is 1 upon 4 pi epsilon naught. By calculation we get it is the work done in bringing up charge from infinity to that point. Now there will be no direction obviously, because electric potential is it is work done, so it is a scalar quantity. Okay. Now we will do some mathematics. The mathematics is that, let we get here, V is equal to, let we are writing Q by, let we are taking C is equal to as Q by 4 pi epsilon naught. Okay. So V is equal to, we are getting C by R, and E we are getting as C by R square into R unit vector. Okay. So this R unit vector, can we write it as C by R cube into R vector? We can write this. Now let we are taking gradient of 1 by R. Gradient of 1 by R. This we are going to solve. Gradient means I cap del del x plus j cap del del y plus k cap del del z of 1 by R means R is equal to root over of x square plus y square plus z square. It is the position vector of any point having the position vector as xi plus yj plus zk. So its modulus will be this. So 1 by R means x square plus y square plus z square to the power minus r. So by solving this derivative, I cap del del x of this thing, j cap del del y of this x square plus y square plus z square to the power minus r, and k cap into the same thing, you will get, you can do the derivation, you will get r vector divided by r cube with a negative sign. Solving this integration, negative sign because there is a power to the power minus r, so you will get a minus sign. So that means gradient of 1 by r we can write as minus r vector by r cube. I am removing the rest part, I will just only write the result here by r cube. Let me clear all these things. Okay. So see, gradient of 1 by r. Now if I write here as C by R, I will write here as also CR by R cube. Now see, CR by R cube is electric field E is equal to minus E. So we can write E is equal to minus gradient of, and C by R is V, gradient of V. So electric field can be expressed as negative gradient of a scalar potential. So here we can make that E is equal to minus of gradient V. And here also one thing we can write, that force is equal to Q into E. If we know the electric field at any point, we can easily find what is the force experienced by other charge placed at that point.